Okay, so first things first, guys. I hope everybody's safe. There was the 5.6 magnitude earthquake that epicentered in Magna, Utah. Um, yeah, so I hope you guys are all okay and that your homes are okay. Here at school, my saber-toothed tiger skull fell off the shelf and cracked on the ground. Um, details about the earthquake are still coming in, but we're going to be studying earthquakes later this year. So it might be interesting if you guys read some of the news articles and learned a bit about this event, and then we can apply it to what we're going to learn later on. But let's jump into today's lesson, which is going to be about A, what did we learn yesterday in our trees investigation, and B, what can you look forward to today as you navigate through the web portal. So first and foremost, let's jump in and review what we learned yesterday. So what's killing these trees? Yesterday you gathered evidence by studying aerial photographs, and after you went through and selected all of the areas and zones, you compared that to historical data, and the conclusion that I hope you guys came to was that if today between 20 and 30% of Utah's trees are dying in the high Uintas, these lodgepole pines, and historically, about 3% have died, then they're dying at a much faster rate today, and it's our job to figure out why. Later on in the investigation, you watched another video about this phenomena, and you looked for signs in trees and what would be causing the trees to die. And it gave you a few options. There was droughts and wildfires, pests and fungus, bacteria, and then it asked you to make a hypothesis about what you thought it was. And as I read through most of your hypotheses, it looks like many of you think either pathogens, predators, or some sort of natural disaster like droughts are to blame. So we're going to today take the evidence that we gathered and start to make sense of it. So this is a bit of analysis that we're going to do today. So let me get back there. And we'll click on analysis. Steps 7 through 14 is what we're working on today. We'll watch another video, and our scientists are going to discuss, things that might be killing the trees. And you'll take what you learn there and apply it to samples as you investigate them. So you can see that these 6 tree samples were taken from that third flyover stop. And what you're going to do is scroll over the images and look for signs of predation and wildfire and drought and pestilence and all of that. So like, for example, here I'm scrolling over this tree and zooming in, and I can see there is a foreign plant growing on the tree limb there. I have discolored needles that have turned brown. Don't see much else there. In this image, in the second image, I can definitely see that lots of bark has been removed. I see those bark beetle galleries, little holes in the bark, and not much else. And in this third one here, which is the cutaway section of the tree, I'm just going to make some observations. It's got thick tree rings in the center when the tree was youngest, but as you move outward, the tree rings are getting thinner and then wider again, and then as I get to the edge, most recently, in the last few years, I can see that those tree rings are very thin or narrow. So, evidence of predation to start. Are there holes in the bark? Yes. Are there bark beetle galleries? Yes. I did not notice caterpillars and moth. There were some foreign plants, these little things right here, on the tree branches. And yes, the needles were discolored. Then I'll click Next. And move on to the second section. Sorry, I gotta move my cursor. Bluish gray inside the trunk. Yes, I do see spots of the bluish gray inside from the pathogens. And I do not see any swelling on the trunk or the branches. Yes, there are discolored needles. Did I do the? Yes, okay. So finally, evidence of wildfire. I don't see any charred bark and I don't see any fire scars, so I can move on. Yes, there are discolored needles for evidence of drought, and yes, we did notice that the rings on the outside of this trunk cutaway were less wide or thinner. You'll go through and do that with all your samples. Then you'll compare your results to others' results in the larger data set. And you can switch between looking at your raw data, number of clicks, and the percentage. Now you can take a closer look at the data that you collected. I like to look as a percentage. And then you're going to look at sort of specific culprits. You know, the holes in the bark, bark beetle galleries, foreign plants, and so on. And you'll do the same with things like wildfire and drought and all of that. And you'll start to draw conclusions. But you want to be careful. They'll teach you a little bit about how to analyze this evidence in this video, and then you'll do the work of analyzing that yourself. You're going to look at patterns and trends in changes in precipitation, temperature, rainfall, in summer and in winter, and you'll note that on your student observation handbook. And then you're done for the day. So I hope that was a useful primer for you, and more than anything, I hope everybody's safe after the earthquake. Don't forget to let me know if you have questions, and I'll be sure to answer those for you. Have a great day, everybody. See you soon.